Hi, it's Jan Beta and I'm going to try to fix this Commodore 64 board today. This is a 250407 board that was sent to me exactly as you can see it here by Wolfgang, who also runs the YouTube channel Retro is the New Black. You might want to check that out if you're interested in retro computers, because he does a lot of interesting content there. Thank you for sending this to me. This looks more like a parts board or parts donor board at this point, because as you can probably see, many of the main ICs are missing, and there were some attempts of repair or rework on this. I always like a challenge, so we're going to go through this whole board and see if we can turn this into a working C64 again. There's quite a few things apart from the missing chips that we need to address to make this work again. I'm going to go through this one piece at a time, and maybe we all learn something. Maybe this is not going to work out, but hopefully it's going to be a fun experience. I always enjoy working on these, as you probably know if you are following my channel, so let's see what we can do. First thing that I noticed on this is that it doesn't have the original on-off switch, but one of these, which should be pin compatible, hopefully, with the originals, which looks something like this. These are the rocking kind of switches, and this is just one of these pole switches, but should be electrically the same, hopefully. We're going to measure that. Then it's missing some chips, of course, the VIC-2, the SID chip, the PLA, the processor, and the kernel ROM, and also a 7406, I believe, logic chip here. I'm going to give this a thorough visual inspection. There are some components that seem slightly damaged, and I'm going to replace those. Then, probably without populating the chips, I'm going to hook this up to a power supply and see if the voltages are somewhat correct. And then we're going to go from there and try to resurrect this. So there are some little things here. This resistor, it has a damaged lacquer part here, but probably that still works. We're going to measure that. Some of these ceramic capacitors also have little nicks, so they got damaged while somebody worked on this. And of course this kernel ROM was desoldered quite crudely. I think there's still some solder residue left in here. There's a ceramic cap that is not connected on one pin here. One of the legs just ripped out. We're going to resolder that. Yeah, of course we're going to have to clean this up and measure the connections to the other chips. Other than that, it doesn't look too bad, I guess. Some rework around the RF modulator here. We're going to have to measure if these connections are still there. I'm going to give this a good cleaning with some isopropanol and see if I can see more after that. This is where the kernel ROM was desoldered and it looks quite crude and not really clean. Let me take a couple of seconds to thank the sponsor for this video, PCBWay, my favorite manufacturer of prototype PCBs of all kinds. They also do CNC machining, 3D printing, sheet metal fabrication, everything the tinkerer needs. Pricing is super reasonable, delivery is fast, and they are very friendly people to work with. So I highly recommend checking out the link in the video description. Back to our C64. First step, cleaning this up a bit, just to be able to see better if there's any traces that are damaged or anything like that. I think this has been worked on quite a bit, so probably somebody tried to fix this at some point. Not sure if Wolfgang did this, but yeah, possibly this was just acquired like this and given up on. And I don't like broken C64s, so I'm going to do what I can. There looks to be some broken traces there. Somebody pulled this chip quite violently, I think. Yeah, so this whole area here around this chip looks pretty violated. I'm just going to try to clean this up a bit more. I think there's still some solder in these holes here. Going to try to clean that up, and probably we're going to have to run some bodge wires around this. Yeah, going to measure this resistor here and possibly just replace it, just in case. Usually if the lacquer is damaged on these are still good. Yeah, that's around 2.7K. That seems to be all right. But yeah, I might still just replace that. And of course I'm going to have to resolder this capacitor here, because that's just, yeah, one leg just pulled out of the solder joint there. Yeah, and that's a red, purple, red resistor. 2.7K as we measured. So that's perfectly fine, but I'm still going to replace it with a better one without a scratch. And resoldering this capacitor here, which is... That actually looks intact, so we're just going to put the same one in there again. And I'm just going to generally clean up some of the work that has been done to this and remove the remaining solder here. Some reworking. Yeah, much better already. So next step is going to be measuring from the connections here, where we're going to put a socket, to the adjacent ROMs. So there's a kernel ROM, a basic ROM, and a character ROM. And they are all basically connected in series. So this should connect to this leg. So the legs are all connected to the same spots. So this hole here should connect to this leg and this leg. And we're just going to measure continuity between these. So, continuity testing. This is actually pretty easy if you don't have a socket in there. Just let's connect it and connect it on here. And this one is connected on here and connected on here. And this one is connected here and here. And so on. Some of these look pretty ripped, but there's through-hole plating in these, so usually you can make a connection if you put a socket in, if there is a connection at all. Doesn't make a connection to this one, so we're going to have to patch that up. I'm just going to mark that. So I marked this with a red marker. Preliminarily, we're going to go through this again. I'm going to solder a socket in, I think, and then patch up the connections that are missing on the backside of the board. This here, I think, might just be not connected, but it might also be a ripped trace in the back of the board on the bottom side. Just going to double check if that makes a connection on a working C64 board. So same revision working board. 1, 2, 3, 4, 5. This should make a connection to here. No, it doesn't. Okay, so this doesn't make a connection here, but here. Let's put a socket in and patch up the connections that are actually missing. Hope this fits already, otherwise we have to remove some more solder. No, goes in fine. Okay. So I'm just going to solder this in. And on some of these, there's definitely some damage, but I think we can make contact on most of the pins here. There are definitely some pins that are not so great. So just going to do the check again from the backside and then patch up the connections that are missing here. Okay, this one's missing, and it's the one we marked. Just patching that up with some magnet wire, I think. Okay. Now we should have a connection there. Yep, and we do. That's nice. So I used magnet wire, which is the wire wound around electromagnets. This is just enameled wire, so you can melt the lacquer that is the insulating layer on this with the tip of your soldering iron, and make small little patch wires like this. There was one broken connection there, and we patched that up. So next step, the strange power switch there. Just going to see how that is supposed to work and compare it to this one here. So here's what our power switch looks like from the bottom side of the board. And I think it's just the center contacts that are switched to the other ones, if I'm not mistaken. So yeah, these two are connected and these two are connected in this position. And when I switch it to the other position, this one is connected. Yeah, these two and these two. So the center pair here is switched to connect to one of the sides, depending on the switch position. Yep, and it should be the exact same for the other switch. The position, which position is on and which position is off, doesn't really matter for this use case. We just want to make this work. So, and here's our funky switch, which I guess is going to do the exact same. Yeah, these two are connected, and these two are not. And in the other position, these two are connected, and these two are not. Okay, so that works fine. I'm still going to reflow this because the solder doesn't even protrude to the other side. So I'm going to put some flux on here and reheat the solder there. And I'm not going to put a proper C64 switch in there. These are not so easy to obtain, so probably somebody just used a more readily available part there. But you can still get these rocker switches that they used originally from some sources. I think this is probably lead-free solder. Doesn't have much of a shiny surface once it cools. Okay, I think now is the point where we power this on, so to say, without the chips populated, and see what the voltages are that arrive at the board and if we see any irregularities there. So this is just a makeshift LED that I made a while back to see if we have any juice going through the board at all, and whether the power switch is in the on or off position. That's basically the main purpose of this. Just a little indication. It's very easy to make these if you have the crimping tool for making these connectors. So I just did. This works with most Commodore machines actually. Okay, powering this on. The LED doesn't light up, but if I do this, the LED lights up. Okay, we have power to the power LED. Yay, that's a win. Let's see what the voltages are. I like to measure them on the user port here. There's two gaps, and you have the two voltages going through the board here. The 5 volts, that's 4.96. That is a tiny bit low, especially considering that there are not too many chips on here. But it should be in spec. It's very close to the 5 volts that are nominal. And we should have our 10 volts AC. That's nominal 9 volts, but 10 volts is what my power supply puts out here. On this gap here, there's two gaps on this connector. Basically, this is the voltage. Yeah, basically, you can determine if the power switch works and if the voltages are somewhat in the right ballpark, which they are on this board. We are going to check the voltage regulators as well. There's two voltage regulators on these older C64 boards, one for 12 volts and one for 5 volts. Just taking the ground from this here, the tab on the... This is our 5 volt regulator, so this should be pretty much spot on 5 volts. Yeah, 5.02. And this is our 12 volts regulator. That should be spot on 12 volts. 12.1. Yep. So these are good. So the voltages that go into the board are all right. And if the voltages are all right, we don't risk damaging any chips. Possibly, maybe, we don't. There might still be some other stuff wrong with this, but we are going to populate the missing chips. I think some of them I have in my stash, some of them I'm going to borrow from other C64 boards because I'm slowly running out of Commodore 64 replacement chips. But still, I want to see if I can make this work, at least temporarily. So, working PLA, we don't have a ROM for that, but going to put a slightly wonky VIC-2 in here. Not using my best chips yet. So slightly wonky. We don't have a ROM here. We need a 7406, but I think I have plenty of those. And at this point we can try to power this on with a test cartridge. I'm going to try to power this on with a dead test cartridge inside, I think, at this point, so we can see what it does. As I said, I used a slightly wonky VIC-2 here that I labeled test only, but it should output something, I think. So, I noticed another thing. Before we power this on, we should set it up to the correct video mode. So there's this little jumper here that says short GPAL and open IPAL, and that's open on this one. But we want this to be GPAL. That's the video standard we have here. So we're going to close that little solder bridge jumper. I think it's closed normally, but this is just open. So we're going to put a blob of solder on there. The oscillator is the PAL frequency, as far as I can tell. So this should be a PAL C64 originally. Yeah, this should be connected now. Yeah, we can try to power this on like this without anything else. Let's see what it does, I guess. Maybe it just works after all. So giving this some juice. Gives me a PAL signal, but a completely blank screen. Of course it does. So here comes the dead test. It gives us an output pointing towards broken RAM. So this somewhat works already. That's pretty good. That's pretty good. Actually, I'm just going to try the DesTest Max and see if that starts up. And we have an output. So this is much better than it was before. So this is what we got. We got several bits here on the address bus showing as black and gray. These are black is a 1 and light gray is 0. So this is our address bus stuck there because it doesn't start up properly, probably. And we have our data bus here, 8 bits, bit 0 to 7, and we can see some faults there, bit 1, bit 4, bit 6 and bit 7. Not great. But still, we get a picture output from this and we get some test results. It's a RAM fault at this point of some description, or a fault with addressing the RAM at least. So yeah, the data line bits that show as bad are always the same. And I realized that there are MOS Logic chips on here. I think I want to replace these before I do anything else, because these have a tendency to fail. I'm just going to desolder these two chips here before I start troubleshooting any further, because MOS Logic chips are very, very prone to failure. Usually, if there's a RAM fault indicated and there's MOS Logic chips instead of these 74 LS257, that's the culprit. But these are, I think, also connected to the data bus, so we're going to desolder these just because they're MOS Logic chips. I don't really like these. It doesn't hurt to get these out anyway. There we go. So the two MOS Logic chips 7712 and 7711 are removed. And the 7711 is equivalent to 74 LS139. The 7712 is equivalent to a 74 LS08. So I'm going to put sockets in here and just put good chips in there, I think, just regular logic chips. Okay, we still have the nearly exactly the same behavior. Yep. It is exactly the same, more or less. So I'm going to assume that these two chips were alright, even if they were MOS parts. Might just be RAM. Maybe we just have broken RAM here. Which of course is a very common fault. And it always stays the same bits, which might hint towards actual broken RAM chips. I guess we're going to have to desolder some RAM. So here's the information we got, the bad bits. I think it might just be multiple broken RAM chips. And we have a table that gives us the information about which data bit is which RAM chip in the manual for the DesTest Max, which this is, and also in the manual for the DesTest, the original Commodore DesTest. We have bit 1, bit 4, bit 6 and bit 7 going wrong. And that corresponds to RAM chips, of course, on the board. And yeah, this is the table. I'm just going by that. U9 is this one. I don't know if these are broken yet or if anything else is broken. Bit 4 is U23. This one. Bit 6 is U24. And bit 7 is U12, which would be this one. So maybe we have 4 broken RAM chips, or maybe something else is wrong. I'm just going to try to desolder, at first I think U9, because that is what the DesTest also indicated, and see if that changes the behavior. If it doesn't, we have something else going horribly wrong here. It's plausible that multiple RAM chips are broken actually, because that's usually what happens if you have a bad power supply. The RAM chips break first. So it might very well be that 4 RAM chips in this case are bad. That's not uncommon, unfortunately, in these C64 boards. But yeah, it might also be one of the logic chips, or a bad trace somewhere or something like that. So I'm just starting with U9 and then replacing that with a good RAM chip, and we're going to see if that changes the behavior in our DesTest Max in this case. And the missing ROM shouldn't Should make a difference. For the test cartridges, at least. Okay, let's put a working RAM chip in there. Let's try that again and see if it changes the behavior. And if it does, it's just RAM faults all the way down. Yep, that cleared bit 1. So chances are that it's just our RAM. Let's try the dead test again, just for kicks. Yeah, that's 4 flashes now. I think that's probably the next RAM chip down the line. So we're just going to replace all these RAM chips, and then maybe we're good. And we need to find a ROM. I don't have a ROM for this. I'm just going to do all at once now. I'm just going to desolder the 3 remaining chips. Just like I did before, so I'm going to stop talking and just do it. So, nice new sockets are in. Let's put some RAM in there. So, yeah, let's try that again. Yay! Okay. That was the thing, the remaining fault. DesTest does its thing. Yeah, the RAM tested. Good. And the CIA's time of day clocks at least are okay. Let's try the dead test. That should start up, hopefully. Takes quite a while to start up this one. And the tests are much slower than on the DesTest. But this should probably pass mostly. It does show me a bit more than the DesTest Max, which is basically just a RAM test with some added functionality, which is super useful. As you've seen, in this case, I just saw all the bad RAM chips in one go. The dead test just flashes according to the first bad RAM address it finds. So you have to redo the testing after each chip that is broken, basically. And with the DesTest, you just get all the chips in one go, as we've seen. I just did that. Yeah, this does some SID testing, which of course doesn't output any sound without a SID in there. But yeah, all our RAM, including the color RAM, is alright. Let me see if I can find a ROM so we can do some more testing. Yup, found one in my parts bin. I think this might actually be one from my father, actually, who desoldered this from his C64 back in the day. But it is not marked as bad or anything, so it should probably work. Let's see if we can test with the diagnostics, which should not start up with this missing. And it didn't, I tried. But it should start up with the... yeah, it does. So now this doesn't do much without the test harness, which I'm going to attach in a second. Yeah, so the ROM is also correctly connected, I think. We should be able to see if the ROM test passes, which is not very in-depth, but it should at least give us some indication. Yeah, we have the basic ROM, character ROM, all good. The things that are showing as bad at this point are due to the missing SID and due to the missing test harness. Yeah, everything else seems to work just fine. That's pretty good. I love that. Okay, so it technically should start up with a basic screen at this point, without the cartridge. Let's try that. Okay, moment of truth. Yay! Blue screen of life. That's pretty lovely. It always is kind of an emotional moment to get something that was as borked as this to work. So the only thing left to do is to run the full diagnostics with the test harness, I guess. And then we can call this a successful repair. As I said, the chips I'm going to have to put back into the other machines, but I just wanted to see if I can make this board basically work. And at some point, I'm probably going to get replacement chips again. If you have any spare replacement Commodore 64 chips, I would be very happy to give them new homes in C64 boards, actually. Okay, got the full test harness connected. And I didn't connect the test cartridge. But this should now pass everything except for the stuff related to the SID chip. Yeah, the control port is it's testing the pedal inputs that are handled by the SID chip, so that shows as bad. And the SID itself shows as bad. But everything else is okay. This is a fully functional C64. Apart from the sound. But the board is okay. Nice. Yeah, that appears to work absolutely fine. Apart from the fact that we don't have sound without a sound chip. No surprise there. So I guess that's it for today. Thank you very much for your time. Hope you enjoyed this. If you are interested in more retro computer repairs, especially focused on the Commodore machines, feel free to subscribe to my channel. Extra special thanks to everybody who supports me on Patreon or on Ko-fi or on the YouTube channel memberships page. The links to that are in the description in case you want to give me some support and make more videos like this one possible. Very much appreciated. That's it. Thanks for watching. I'm Jan Beta. See you next time. Bye.